All right, welcome back. Today we're tackling a really interesting problem. How do you clean the uncleanable? I'm talking about massive spaces. Think warehouses, stadiums, factories. So how do you even begin to sanitize an environment that's almost impossibly big? Yeah, forget about cleaning your living room. We're talking about places with just insane square footage, ceilings that are stories high, and all kinds of complex machinery that creates countless nooks and crannies. You know, the usual cleaning methods, they just don't stand a chance. So how do you actually pull it off? Well, it really comes down to a choice between two totally different worlds. On one hand, you've got manual spraying. You know the drill. It's slow, it takes a ton of manpower, and you can only clean what you can see. But on the other hand, you have high-performance fogging. This is a method that treats the entire volume of air in a space for total 360-degree coverage. It's a complete game changer. So, first, let's really dig into what we mean by the large space problem. When you're dealing with this much volume, just wiping down surfaces is, well, it's like trying to empty the ocean with a bucket. The sheer scale of the challenge means you need a completely different way of thinking. So, what's the solution? It's pretty cool, actually. It's all about the science of the fog itself. The magic here isn't just turning some liquid into a mist. It's about engineering that mist on a microscopic level. Because when you're talking about total coverage, size is literally everything. The key technology here is something called ultra-low volume fogging, or ULV for short. Now, this is a cold, mechanical process that atomizes liquid into unbelievably fine particles. And here's the critical part. The goal isn't just to get surfaces wet. The goal is to create this suspended cloud that completely saturates the entire volume of air. And the magic number? The ideal droplet size is between 10 and 50 microns. Now, just to give you some perspective, a single human hair is about 70 microns thick. So we're talking about droplets that are so tiny, they're basically invisible. And that is the secret sauce that makes them so incredibly effective. So why is that tiny size so perfect? It all comes down to what's called the stay time factor. See, droplets this small are so light that they just float on the natural air currents instead of dropping straight to the floor. This means they can get carried everywhere, bypassing obstacles and reaching all those hidden shadow areas, like under tables or behind big pieces of equipment. That's how you get true 360-degree coverage. But having this amazing science is one thing, it's not the whole story. To get professional results, it's all about strategy. You can't just stick a fogger in the corner of some giant warehouse and, hope for the best. There are specific techniques that are designed to maximize coverage in all kinds of different environments. First up is HVAC integration. This is the whole building approach. For any place with central air, you can introduce the fog directly into the intake vents. The building's own HVAC system then becomes your distribution network, pushing that sanitizing fog absolutely everywhere. And here's a pro tip. You've got to bypass any HEPA filters first, otherwise they'll just trap the fog before it can do its job. Okay, but what if you're in a huge open space that doesn't have ductwork, like a gymnasium or an airplane hangar? That's where multi-point saturation comes in. For this, you use multiple foggers placed strategically around the room, and then you bring in large fans to create these powerful air currents. You're basically creating a swirling vortex of fog that keeps it all agitated and suspended, making sure it covers the entire space nice and evenly. And this brings up a really important point. Not all fog is created equal. Sometimes the challenge isn't the width of the space, but the height. For super high ceilings, pros often use thermal fogging. This uses heat to create a really dense fog that naturally rises. On the other hand, the cold ULV fog we've been talking about is way better for general saturation and is definitely the safer choice when you're working around sensitive electronics. Okay, so you've got the science, you've got the strategy, but none of that matters if you don't have the right gear. We're talking industrial scale jobs, and that requires industrial grade power. Your standard little handheld fogger, it just isn't going to cut it here. So what are the absolute non-negotiables for pro-level gear? Well, you need a high flow rate, because that means speed. You need a large tank capacity, so you're not constantly stopping to refill. You've got to have a projected reach of at least 25 feet. And, of course, you need a seriously powerful motor, either gasoline or high voltage, to sustain that kind of output for hours. We've covered the science, the strategy, the gear, but now let's talk about the most critical piece of the puzzle, safety. When you're turning chemicals into an aerosol that fills an entire building, following strict protocols isn't just a good idea, It's an absolute necessity. The safety protocol is a really clear 4-step process. Number 1, the operator has to wear full PPE, and that includes a respirator, no exceptions. 2, you have to disable the smoke sensors. 3, the entire space must be empty for 2 to 4 hours. This lets the fog do its work and then settle. And finally, number 4, the building needs at least 30 minutes of active ventilation before anyone can safely go back inside. You know, this quote really sums it all up perfectly. High-performance fogging isn't just about having fancy equipment. It's about the strategic application of fluid dynamics. It's about understanding how an engineered mist is going to behave in a massive, complex environment to get a result that would otherwise be completely impossible. So the next time you walk into one of those huge, perfectly sanitized spaces, you'll know a little bit about the science and strategy that likely went into it. And it kind of leaves us with one last question to think about. When it comes to getting things truly clean on a grand scale, is the conventional approach just scratching the surface?